Hello students, my name is Adar Ali Khan and I am going to tell you the concept of complex number. So before starting any topic, we need to understand what the topic is, that is obvious, and why do we need this topic. Okay, so first we consider why do we need complex number. And complex number is nothing but it is just the combination of real and imaginary number. Okay, what is the complex number? Complex number is the combination of real number plus imaginary number. Okay, now the second part, why do we need this complex number? Okay, why do we need this topic? So before we understand why do we need to understand what is imaginary number. Okay, what is imaginary number? So let us consider an example, root 4. So it gives us plus 2 and minus 2. Okay, and also root 1 will gives us plus 1 and minus 1. Okay, if we square plus 2 it will give 4, and if we square minus 2 it will also give 4. Similarly in this case, if we square plus 1 it will give 1, and if we square minus 1 it will also give 1. So we can conclude this we can conclude with these examples that if we square any number, either it is positive or negative, we square any number, it will give us always positive number. Okay, so let us consider third example, root 9. So root 9 will gives us two values, either one is positive and one is negative. We already know the one is plus 3 and another is minus 3. Okay, so using these example we can conclude that no real number is negative within a root. Okay, because if we square any positive number or any negative number, we always get positive number. So we cannot consider any negative number in the root. Okay, so this is just the basic building. Okay, basic building block. Now let us look. Consider x square plus 1 equal to 0, a quadratic equation. Okay, and you already know that if a quadratic there always are two root in a quadratic equation, because of the x square, the degree of this equation is 2, so the value of a variable also gives us two values. Okay, so now solve this equation. X square plus 1 equal to 0, that will becomes x square equal to minus 1, and when we square go that side of the equal sign, then it will be root minus 1. Now this is the flow, minus 1. We already discussed there is no negative sign within a square root. Okay, so where this sign comes from? So this is the flow. So if this is a flow, so the mathematics will end from here, but no. Here is the imaginary number come into play. What is real number? Real number is the number which we can represent on a number line. Okay, real number are the numbers which we can represent on a number line, like 0, 33 by 11, okay, minus 272. These are the real numbers. But those numbers, what? This real number, this is the real number, this is real number, this is real number. But those numbers which we cannot represent on the number line, we can only imagine that number. Okay, that number should be considered as imaginary number. And here comes the imaginary part comes into play. So this will consider as root minus 1. Listen, root minus 1 will be considered as I. I represent the imaginary number. Okay, so x is equal to plus minus I, because x have two values. The one is plus I and another is minus I. I is nothing but it is just the representation of an imaginary number. What I'm saying, that I is just the representation of an imaginary number. So if we represent root minus 1, so it will be I. And again, if I represent root minus 2, then it will be represented as root 2I. I is outside the root because the value of I is root minus 1. So root minus 2 should be written as root minus 2 into root minus 1. So root minus 1 is I and root 2. This is a positive. Okay. So this is the imaginary number. And why? So this is the reason why we need complex number. Okay. So now what is the just representation of the complex number? Complex number is represented as is a real plus imaginary number. Okay. So let us consider any real number A and imaginary number. Let us consider any imaginary number B. Bi. Why I? I is a imaginary number. Iota. B is a real number. Here A and B are real number. Okay. If we write root minus 1, then it will be I. And if we write 2 root minus 1, then it will be 2I. So 2I will also be the complex number. 2I is the also be the complex number, but it has 0 real part. It can be written as 0 plus 2I. Here A is equal to 0 and B is equal to 2 as compared to this. This is the complex number. Okay. And complex number should be represented as Z, by Z. Complex number should be represented as Z. So what is the general form of the complex number? The general form of the complex number is Z is equal to A plus Bi. Okay. So now if we were in first and second class, we know about what is the numbers. Okay. What is the numbers? So we going to the higher classes, we consider A plus B, addition of a number, subtraction of a numbers, multiplication of a number and division of a number. Okay. Similarly, we can learn here the addition of complex number, the addition of the subtraction of complex number, the multiplication of complex number and the division of the complex number. So first of all, we consider two complex numbers, because if we add any two any numbers, so we require two numbers. So we add complex numbers, so we require two complex numbers. The first complex number should be Z1. Z1 is equal to 2 plus 3I. This is just an example. And Z2 is equal to minus 3 plus 4I. Okay. This is the complex number. This is A, this is B, this is I, and this is A, this is B, this is I. So this is the real part and this is the imaginary part of the complex number. Similarly here. So if we add Z1 plus Z2, okay, if we add these numbers, so Z1 is 2 plus 3I plus Z2 is equal is minus 3 plus 4I. If we add those numbers, then we have to add real part to the real part and imaginary part to the imaginary part. So this should be considered as 2 minus 3 plus 3I plus 4I. Okay. So real part should be added with the real part and imaginary part should be added with the imaginary part. So 2 minus 3 is minus 1 and 3I plus 4I is 7I. So the addition of two complex number of this complex number is minus 1 plus 7I. Okay. Similarly, we can also do subtraction, Z1 minus Z2 as well. Okay. So what is 2 plus 3I minus Z1 minus Z2, right? So 3 plus 4I. Okay. If we consider this, then the real part should be subtracted with the real part and imaginary part should be subtracted with the imaginary part. So 2 minus 3, 2 minus 3, right? This minus 3 and this minus 3, no, this is a minus 3. Okay. So 2 plus 3, this minus should be a plus. Okay. And plus 3I minus 4I. Okay. So this will become 5 plus 3i minus 4i should be minus I. So this will become minus I. So the subtraction of these complex number is 5 minus I. The addition of these complex number is minus 1 plus 7i. Okay. So in the addition and subtraction, the real part should be added or subtracted with the real part, and the imaginary part should be subtracted or added with the imaginary part. Okay, so this is the addition and subtraction of a complex number. Now we consider now we are going to multiply. Okay, we consider two complex number. Z1 is 2 plus 3i and Z2 is minus 1 plus I. Okay, these are the two complex number. Now we need to multiply these two numbers, Z1 into Z2. So Z1 is 2 plus 3i and Z2 is minus 1 plus I. Okay, multiplication should be easy. Multiplication is similar to the multiplication of the actual numbers. This is the complex number of real numbers. So 2, first we multiply this with the whole bracket, and after that we multiply this with the whole bracket. 2 minus 1 plus I plus 3i minus 1 plus I. Okay, now multiply. Minus 2, it should be 2i, it should be minus 3i, and it should be plus 3i square. When you multiply 3i into I, then 3 and I into I square. Okay, now we will discuss I square later. Minus 2, 2i minus 3i should be minus I. Now plus 3. What is I square here? We consider what is I square here. As we know, I is equal to root minus 1. Okay, I is equal to what? I is equal to root minus 1. So what should be the I square? What should be the I square? We need to square this number, and square root and square should be cancelled out. Then I square should be considered as minus 1. Right? Now I can write this as well. Root minus 1. What is the value of I? I is equal to root minus 1. Then what is the I square? Root minus 1 to the power 2. Then it will become 1. Right? Because square root and square should be cancelled out. So I square is 1. So this should be not 1, minus 1. Okay, square and root, this is the minus 1. So this is minus 1. Now minus 2, minus 3 should be added. It is minus 5 and minus I. So the multiplication of these two complex number is minus 5 minus I. If we compare to the general form of this of the complex number, then the real part A is equal to 5 minus 5, and the imaginary part B is equal to minus 1 here. Okay, this is the I. So this is just the multiplication. The division should be discussed in the next video, because it is a long method. We have to rationalize these numbers. If we divide these numbers, we have to rationalize. Then we make a denominator as a real number, something like that. Okay, but one more thing we need to discuss, that I is equal to root minus 1. Understand? I square is equal to minus 1, as we know. Okay, so what is I cube? What is I cube? I cube should be written as I into I square. Okay, I should be written as I into I square, and we already know the value of I and I square as well. Okay, so what is the value of I square? The value of I square is minus 1, and I should be written as it is. So the value of I cube is minus I. Okay, what? The value of I is under root minus 1. The value of I square is minus 1. Okay, and the value of I cube is minus I. Understand? The value of I cube is minus I. Now, what is the value of I to the power 4. What is the value of I to the power 4? We can calculate it in two ways, but I square should be written as I to the power 4 should be written as I square into I square. Okay, I square into I square. What is the value of I square? The value of I square is equal to minus 1, and the value of I square should be minus 1, so minus 1 into minus 1, that should be 1. So this is the important part. What? The value of I to the power 4 is 1. Okay, so first number is I. When we square I, we get minus 1. When we cube I, we will get minus I. If we power 4 to the I, it will get 1. So according to this rule, we can say that the multiple of 4 in the power of I, imaginary number, okay, in the power of imaginary number, I4 equal to 1. So we can conclude that I to the power 8 should also be 1. Why? Because I to the power 4 should be, I to the power 8 should be written as I to the power 4 into I to the power 4. That will 1 and 1 into 1 is equal to 1. So that's why I to the power 8 is also 1. Similarly, I to the power 12 is equal to 1. I to the power 16 is equal to 1. So multiple of 4. We can generalize this trend. I to the power 4n is equal to 1, where n belongs to whole number. Okay, we start n from 0 to infinite. Then the multiple of 4 in the power of I should always gives 1. Similarly, the multiple of not the actually multiple of 3. Okay, so we can if we calculate I to the power 272. So what is the value of I to, this is the last topic I am discussing here. What is the value of I to the power 272 or 273? Let us consider I to the power 273. First, we need to check 273 is divisible by a 4 or not. It is obvious that it is a odd number, it is not divisible by 4. So we can convert it into the I to the power 4. Okay, so 273, we need to divide 273 by 4 by long division method. It should be 6 4 ja 24. Okay, 3 33, 8 4 ja 32, 1 is remainder. Okay, we need to consider the remainder as well. So 68 4 ja 272, because 1 is remainder. 68 4 ja. So we can break this. We can break this 273. We can break this 273 with 4 into 68 plus 1, because 1 is the remainder, 68 is the quotient, 4 is the divisor, and 273 is the dividend. Okay, so 273 should be written as 4 into 68 plus 1. So this 273 should be written as I to the power 4 to the whole power 68, because when you multiply 4 into 68, it will become 272 and plus 1. So where we get that 1 as well? This is I to the power 1 or I. If the remainder is 3, then it will be I cube, and if the remainder is 2, then it will become I square. Okay, so the remainder is 1 here, so it will be I. So we know what is the value of I to the power 4. It is 1 to the power 68 into I. 1 to the power 68 is 1 I, so the final answer is I. The value of I to the power 273 is I. Okay, this is the way of calculation.